What are the general possible models related to GATE exam? And in each topic I want to make a review. So what are the final points we have to remember in the process of attempting questions related to GATE exam? So first and foremost, with respect to signals, the basic signal that we are using is impulse del of t. How it is related in terms of step function is d by dt of u of t. In the opposite way, we are saying unit step is integration of impulse. Unit step is integration of. What is the change we considered for a discrete case? Differentiation converted to difference. Opposite way, u of n equals to sigma 0 to infinity del of n minus k. So these are the relation between the basic standard signals, impulse, step function, like that. But we are aware h of t is called as the impulse response, maybe discrete case h of n. If whenever you apply step function as input, the respective output is called as step response. Impulse is the input, respective output is impulse response, step is the input, respective output is step response. So how these relations are modified for their respective outputs? Del of t replaced as h of t, d by dt of u of t is replaced as s of t. In the opposite way, s of t is integral h tau. What is the change we can make? Discrete case, h of n is Sn minus s of n minus 1, whereas here s of n is sigma 0 to infinity h of n minus k. Or you can also say that as sigma minus infinity to n hk, no problem. That is also a valid relation. So these are some standard test signals. Basically, impulse and step are the standard test signals we are using. These are their input relations. The respective output we are calling as impulse is the input, impulse response is the output, step is the input, step response is the output. Based on these relations, regularly in my observation we are getting 1 mark model. So be thorough with that relations. Be thorough with them. You are aware continuous impulse is represented with arrow mark, that is maintaining infinite amplitude level, but discrete impulse is having a finite amplitude of 1. Del of n, it is finite length signal of finite amplitude, but continuous impulse is approximated version of standard signals. Okay. So these are some of the standard relations. You must be thorough. Some of the standard relations. So the next observation which we have to make is, what are the standard properties of continuous impulse? One property, area under unit impulse function is 1, that is generally called as area or strength of the impulse. Area under unit impulse is 1. What about scaling property of impulse? Del of alpha t is 1 by mod alpha del of t. Del of alpha t is 1 by mod alpha del of t. But equivalent to discrete case, when you want to scale the discrete impulse by a factor k, it is always del n. Del kn equals to del n. When you want to scale the discrete impulse, answer remains same. Then we have to observe that energy and power signals concept, which is also one regular model for us. Energy and power signals. Which type of signals are energy signals? For an energy signal, we are aware average power is 0. Which type of signals are energy signals? One possibility, as t tends to plus or minus infinity, if the amplitude is tending to 0, such signals are energy signals. Examples like decaying exponential or a Gaussian function, which are obeying this property, as small t tends to plus or minus infinity, amplitude tending to 0. That is one possibility. Another possibility, finite length signals of finite amplitude. Finite length signals of finite amplitude are also treated as energy signals. So, how we studied those relations in regular classroom discussion? When you take rectangular pulse of width t having amplitude a, fixed energy answer is how much? A square into t. When you choose half cycle sinusoid, when you are choosing half cycle sinusoid, then the energy answer is how much? A square t by. When we choose a triangular pulse of width t, then the energy answer is A square t by 3. When you see old papers, there are so many models related to the standard signals. Certain times they will add rectangular, triangular pulse. So be careful when you are attempting that model. Fixed energy in the rectangular pulse is A square t. Half cycle sinusoid is A square t by 2. Triangle is A square t by 3. So there are two possibilities for energy signals. One possibility, as a small t tends to plus or minus infinity, amplitude is approaching to 0. All finite length signals of finite amplitude are also treated to be energy signals. Finite length of finite amplitude. So for an energy signal, the average power will be 0. For an energy signal, average power will be 0. Which type of signals are power signals? Which type of signals are power signals? So for that I am going to the next slide. So for power signals, generally energy is infinity. Signals that maintain constant amplitude over infinite time. Signals which are maintaining constant amplitude over infinite time are considered to be power signals. To tell you a few examples, suppose we have taken step function of amplitude A, fixed answer is A square by 2. But when you try to take constant for all time, A for all time, constant everywhere, A for all time, simply A square. Of course, periodic signals, when you take cos or sine, generally periodic signals are treated to be power signals. Based on the RMS value concept, we are saying power is A square by 2. All periodic signals are power signals. All periodic signals are power signals. When there is a chance for neither nor, NENP, neither energy nor power, NENP, neither energy nor power. At any instant, amplitude is tending to infinity. At any instant, signal amplitude is tending to infinity. They are considered to be neither energy nor power. Examples like ramp. What is ramp function nature at infinite time? As t tends to infinity, amplitude is infinity. Or if you take a general decaying exponential which is there for all time, a general decaying exponential which is there for all time. So when you see this graph, as t tends to minus infinity, its amplitude is going to infinity. At any instant, the amplitude is tending to infinity means that is neither energy nor power. When we add a power signal to energy signal, resultant is power signal. When you are adding power signal to energy signal, resultant signal is power signal. So there will be a definite model related to energy and power signals concept. There will be a definite model. Few models I am solving with respect to frequency domain. So after few minutes you will understand few models. For a better idea, I have chosen some best examples that we are going to solve after some time. So be thorough with these statements. Energy, power signals is a regular model for us with respect to exam. Energy signal average power 0, power signal energy is infinity. A signal cannot be both energy and power signal simultaneously. A signal cannot be both energy and power signal simultaneously. So next important concept we require here is concept of periodicity. Concept of periodicity. So normally what is periodic signal condition? What is periodic signal condition? X of t equals to x of t plus or minus m into t naught, where t naught is the fundamental period of xt or least period of x of t. So with respect to continuous case, which are the standard periodic functions? When you choose sinusoids separately, cos omega naught t plus theta, sin omega naught t plus theta, e power plus or minus j omega naught t, they are separately periodic for any choice of omega naught. Individually they are always periodic functions individually. But what happens in discrete case? Discrete case periodicity is like this: x of n is x of n plus capital N, where capital N is the period of x of. Discrete case, what is the change? Cos omega naught n plus theta, sin omega naught n plus theta, or e power plus or minus j omega naught n. They are periodic if and only if, what is the requirement? Compulsory. Omega naught by 2 pi ratio is a rational number, m by capital N. You are aware, gate 24, you got a model related to this. Gate 24 with respect to discrete signal. These are for individual signals. These are for individual signals. What about when you are trying to add multiple signals? Individually we said like that. When you want to add multiple signals like either continuous or discrete, it may be continuous or discrete. When you have sum of so many signals, something like this, how to decide whether they are periodic or not? Simply take greatest common divisor of individual signal frequencies. If we are assuming first signal periodic with time period t1, t2, t3, you are aware omega naught is 2 pi by capital T, fundamental frequency is 2 pi by capital T. So it may be continuous or it may be discrete. to decide whether the overall signal is periodic or not, use that logic. GCD of individual frequencies. So this is also one regular question you can expect in the exam. Compulsory question will be there on periodicity, compulsory model. If x of t is periodic with a time period of capital T, find time period of what is the common period of this function x of 2t plus x of 0.5t. Original signal is periodic with time period of t. I am asking the overall period of added signal, that is scaled, x of 2t plus x of 0.5t. So let me take a simple example here, x of t as e power j omega naught t, which is a periodic function having time period of capital. Generally omega naught is 2 pi by t. Omega naught is 2 pi by. So what is the meaning of this one? E power j 2 omega naught t, e power j 0.5 omega naught t. So further it is like e power j 2 omega naught t one term, e power j omega naught by 2, as we are using our GCD logic. Here this can be adjusted as 4 omega naught by 2 e power j omega naught by. So what is the common frequency they have? What is the common frequency? Omega naught by 2. We have fourth harmonic and first harmonic. Common frequency is omega naught by 2. Omega naught by 2. We have fourth harmonic and so what is the time period? Of combined signal. What is the time period of combined signal? 2 pi by omega naught. What is omega naught here? What is the common frequency they have? Omega naught by. So 2 pi by stroke is more. Okay. Answer is 2t. Let me denote for your understanding that as t naught. So for your understanding purpose, I have chosen a simple function e power j omega naught t, assuming the time period as capital T. After that I have substituted, as our expectation is GCD, I adjusted 2 omega naught as what? 4 omega naught by 2, such that the common frequency is omega naught by 2. Time period is 2 pi by omega naught, but what is that common frequency we got? Omega naught by 2. Omega naught expansion is 2 pi by t, substitute there. So the common period becomes 2t. Consider the continuous signal. It is given as two complex sinusoids with extra DC. It is sampled, uniformly sampled with a sampling frequency of 100 Hz. What is the time period of discrete signal? How to convert continuous to discrete? T place NTS. Fs is 100 Hz. Ts is 1 over Fs. Take the discrete form x of NTS. When you take the discrete form, small t place we are substituting n by 100. Now we got the new frequencies like 4 pi by 7, 2 pi by 5. 4 pi by 7, 2 pi by 5. When we are adding multiple signals, even in discrete case, what is the direct logic? Simply select GCD. 7 5s are 35, that is a common multiplier. So to make the denominator same, because our expectation is n omega naught harmonics concept, integer value of fundamental harmonics concept. So what adjustment I have to do? To make common denominator, numerator denominator in this case multiplied by 7, in this case it is multiplied by 5. So this is indirectly GCD of which numbers? 20 pi by 35, comma 14 pi by 35. Indirectly they corresponds to which harmonics? What is the common number they have? 20 pi by 35, 14 pi by 35 means what is the common number they have? 2 pi by 35. 2 pi by, this we feel like 10th harmonic, this we feel like 7th harmonic. So time period is, as omega naught is 2 pi by n generally, which we got as 2 pi by 35, n value how much? 35 samples or not? N value is 35 samples. So first you have to convert continuous to discrete signal. For that, small t replaced as n into ts. Later on we got discrete form. As they are not individual signals, no need to verify omega naught by 2 pi is m by n separately. No need to verify separately. Simply take GCD. We need some adjustment because we need always harmonics logic. Make the denominator same. Make the denominator same. Hope you have followed me. This particular example. Explain the difference between following operations. There are actually 3 properties of impulse. 3 different properties of impulse. Any one property is regular in competitive exams. Any one property. To answer the first one, we need product property of impulse. Xt into del of t minus t naught equals to x of t naught into del of t minus t naught. First one is product property. Xt into del of t minus t naught means check the signal at the respective shift. Second one is sampling or shifting property. Integral t1 to t2 xt into del of t minus t naught dt equals to simply x of t naught. Shift should lie within the limits. Whereas the last one is indicating convolution property of impulse. Convolution property of x of t convolved del of t minus t naught equals to x of. So be careful when you are using these properties. First one is e power minus t ut into del of t minus 1. So it becomes e inverse into del of t minus 1. Directly replacing the function that instant, e inverse into del of t. Next one is directly representing the shifting property. Check the signal at that instant. Check the signal at that instant. Last one is convolution, signal shifted by that much amount. Signal shifted by that much amount. So don't confuse between the properties of impulse to confuse us what that fellow will do in the exam. He may ask convolution question, but other two bits answers, other two properties answers may be provided. Be careful. Product property is retaining impulse at that instant as it is. Shifting property is making that as a constant value if the shift is within the limits. But convolution is shifting that signal by that much amount. Del dash is not that much important, double it, but it is only for property sake we will use it. There is no such importance about that function. Only the sampling property can be extended to derivative. With respect to gate paper, they have never touched a question related to that. Only the shifting property can be extended to derivatives. Something like this. Whatever the differentiation that impulse contains, that is shifted to the signal. -1 whole power n d power n by dt power n of xt observed at shift. Not only signals, every subject, whatever the standard relations or standard conditions that are there, be thorough. Because in the examination, immediately you should get the thought. By seeing the integral, if the integral has impulse, immediate thought you need is application of shifting property. If the word convolution is used, or input known, system known, get the output means we are using convolution. If one of the signal is impulse, blindly convolution property of impulse. Approaching the given question is most important with respect to gate paper. Understanding the given data. There only generally we are lacking. Okay. Let me discuss the next point. They may ask one question related to systems classification. So let me discuss what is generally linearity of a system condition. Sum of scaled input signal should produce sum of scaled outputs. Generally we are calling that as superposition, that is satisfying additivity and scaling. Second one is the time invariance. What is time invariance condition? Output due to shifted input must be equals to direct shifted output. Output due to shifted input. Then we are dealing with causality. Causal system means present output should depend on, it must be function of present output should depend on present past inputs as well as past outputs. Present output depends on present input, past inputs as well as past outputs. Superposition itself is combination of additivity and homogeneity. Be careful. Additivity, homogeneity, they are combinedly called as superposition. Static or memoryless system. Generally, what is static or memoryless system definition? If the input and output are observed at the same instant, then it is static. Input and output must be observed at the same instant, then it is static system. Then stability. Concept of stability is linked to bounded input, bounded output. If absolute value of input is taken as some finite number, then if we try to make magnitude of output also finite, then it is stable, otherwise unstable. Stability, linearity, they have amplitude dependency. Stability, linearity. Okay. So, let me give two examples. If the system obeys the property, I will make tick mark. If it fails, I will make cross mark for you. As I used the word system, I am discussing one example for you on this concept. One example. Okay. I am moving to next slide. System linearity, time invariance, causality, static stability. If it is obeyed, let us make a tick mark. Think of this example, yn equals to xn into stream of impulses sigma minus infinity to infinity del of n minus 2k stream of impulses. Yn equals to xn into stream of impulses sigma minus infinity to infinity del of n minus 2k. Think of course it is linear. This is a fixed function. y1n is x1n, y2n is x2n. It is linear. But time variant. Why it is time variant? When we try to shift the input, only xn part is changed. When we try to shift the input, only x of n is shifted by n naught. This remains same. When we shift the complete output, wherever n is there we are writing n minus n naught. So it is a variant system. Causality requirement, present output should depend on present input. It is satisfying. Of course it is static, as the input and output are observed at the same instant. Static. Once the system is static, automatically it is causal. You are aware of that point. All static or memoryless systems are causal. All static or memoryless systems are causal. 100% it is stable. Because for stability, magnitude of input is finite, that is compulsory requirement. If we draw the stream of impulses, those stream of impulses may extend for infinite length, but their maximum amplitude is how much? The stream of impulses may extend over infinite length, but their maximum amplitude is 1. So this has maximum amplitude of 1. Compulsory requirement is mod xn must be finite. Automatically mod yn also finite. System is stable. Let me see your response for this. Another system I have given. X of t minus 5 minus x of 3 minus t. X of t minus 5 minus x of 3 minus t. Think of the three properties. Not 3, 5. Of course it is linear. Time variant. How I am saying? Second term has a time reversal x of 3 minus t. Which are the general time variant operations? Modulator, time scaling. If the input or output is an external function of time, they are time variant. One is modulator, signal multiplied by cos or sine. If it is external function of time as well as time scaling variant. Causal or non-causal? That is a failure, non-causal. How? Suppose we are substituting an instant like t equals to minus 1. T equals to minus 1, it becomes x4. You are checking output at minus 1, input is taken at 4. You are checking output at -1, input is taken at 4. Of course, dynamic, very clearly 100% stable, because when you shift or fold the signal, amplitude is not affected. Whenever we are shifting the signal or folding the signal, amplitude is not affected. So, with respect to gate paper, by giving the system, they will ask you 2 to 3 properties of system. Be thorough. 2 to 3 properties. Okay, let me discuss the next concept. This is also one standard question. LTI system property. Consider an LTI system whose response to the input x1t is y1t. What is the response of the system due to the input x2t and x3t? So, what is LTI system property? Whatever the relation that is applicable for inputs, same relation is equally applicable for outputs. So, when you see the upper segment of x2t, you can feel this like x1t, but the lower segment of x2t is shifted version with amplitude scaling. Try to express the relation between the inputs. Try to express the relation between the inputs. We will get the relation between outputs. What is LTI system property? Whatever the relation that is applicable for inputs, same relation is equally true for respect to outputs. Whatever the relation that is applicable for inputs, same relation is equally true for respect to outputs. For an LTI system, find the relation between the input signals. Same relation is equally true for respect to outputs. In a similar way, how to get the relation between x3t and x1t means, suppose I am choosing x1 of t plus 1. What is the need to choose x1 of t plus 1? Because x3t starts at -1. If I try to add these two functions x1t and x1t plus 1, we will get that. So, x3t equals to x1t plus x1 of t plus 1. As the system is LTI, y3t equals to y1t plus y1 of t plus 1. When you try to add the two triangles, I am giving the final graph for you, you check it. You are going to get the graph like this. This is y1t, y1t plus 1 means left shift of 1 unit by adding them. That is a resultant graph that will be obtained. For an LTI system, whatever the relation that is okay for input, same relation is equally true for respect to output. One standard question. They can ask this LTI system question with respect to filters, ideal filter, practical filter, or a practical transfer function means Laplace domain, ideal case means Fourier domain, but that LTI system property model is regular model. For an LTI system, whatever the relation that is applicable for inputs, same relation is equally true for respect to outputs. That is the point of observation there. Okay. Think of this particular model. System 1 compress the signal by a factor 2. Means he is saying if xt is given, output of system 1 is x of 2t. If x of t is given, output of system 1 is x of 2t. System 2 is an RC low pass filter with the time constant 1. For an RC filter, what is the standard impulse response? What is the standard impulse response of RC filter? You all aware. E power minus t ut. E power minus t ut. So on the lower combination, he interchanged the blocks. On the lower combination, he interchanged the blocks. Whether the final outputs are equal or not, that you have to tell. Shiva, what is there? If I am adding this function and this function, I am getting x3t. y1t added to y1t plus 1. What is y1t plus 1 graph? That original triangle left shifted by 1 unit. Simply add them. Minus 1 to 0 ramp segment as it is. 0 to 1 positive ramp added to negative ramp, that becomes constant. 0 to 1 portion. This is a positive ramp, this is a negative ramp. 1 to 2, that remains same. Trapezium. X of t, he wants to give input as this one. What is that? 2 e power minus t ut. This is compressed by 2. So, what will happen there? 2 e power minus 2t u of 2t. Let me name this as y1t, y2t for understanding. First combination output I am writing as y1t, second combination as y2. Anyway, scaled version of step function is itself. What is system 2 here? He has mentioned there is a RC low pass filter with a time constant of 1. So, y1t is nothing but here 2 e power minus 2t ut convolved with this low pass filter impulse response e power minus t convolved. See, compressed by 2 means wherever t is there, we are taking 2t. Scaled version of step function is ut. Input to the system is this expression convolved with that. So, if I take Laplace here, because that is an easy tool for us, so it becomes 2 by s plus 2 into s plus 1. E power minus at ut, here also e power minus at. If you do partial fraction expansion here, what will happen? S place minus 2 residue will be s place minus 1 residue will be 2. Simple partial fraction you do. S place minus 2, that is giving us minus 2, s place minus 1 is giving. So, what is the inverse Laplace of each term here? Minus 2 e power minus 2t ut plus 2 e power minus t. That is first system output. But when you check B bit, you want to pass the input through first low pass filter. What is the fixed impulse response it is having? E power minus t ut. Later on pass through compressed by 2. Compressed by. Anyway, this is simply convolution of these two, that is 2t e power minus t ut. You are all aware of that. E power minus at ut convolved by itself means 1 by s plus a whole square standard relation. Here t is replaced as 2t. T is replaced as 2t. Of course, we got that as 4t e power. the final outputs are not equal. Why they are not equal? Why they are not equal? Because one of the system is a variant system compressed by 2. Compressed by 2 is a variant system. That is the reason final outputs are not identical. Only if the considered systems are LTA, even we interchange the blocks, final outputs are identical. Only for LTA system, not for every combination. Only for LTA system, even we interchange the blocks, final outputs are identical. Why in this particular case answers are not same? Even we interchange the block, because one of the system is variant. Which system? Compressed by 2. Compressed by 2 is a variant system. So, for that purpose I have chosen these two examples simultaneously. For an LTA system, whatever happens to input, same thing happens to output. But it is not the case here. As one of the considered system is variant system, final outputs are not identical. Hope you got my point. Okay. Why the outputs are not identical means compressed by 2 is a variant system. But if they are individually LTA, if the two systems are individual LTA, we can blindly interchange the block. That is what we are learning even in controls. GS into HS is HS into GS. If the considered system is LTA. Only if the considered systems are linear time invariant, even we interchange the blocks, final outputs are identical. Even we interchange the blocks. System 2 is here compressed by 2 in the lower example. When you convolve decaying exponential with itself, this is the standard answer. Compressed by 2 means whatever the input you are giving, their t is replaced as 2t. Their t is replaced as 2t. But u of 2t is ut from its definition. U of 2t is ut from its definition.